Alright, welcome to the coding session of lesson 11. Remember, we already had a coding session in lesson 11, and that was a coding session about random forests. Yeah. Today we're gonna do a session on gradient boosting. Yeah, remember, boosting is applied when you have a bias problem. And we had two ways or two boosting methods. One was add a boost, we did an exercise on this, and the other one was gradient boosting. Yeah? So this coding session will be about gradient boosting, and the library that we will be using will be XGBoost. XG, Extreme Gradient Boosting. It's actually gradient boosting on steroids. Yeah? It's very fast, it's accurate, and it scales. Yeah, it scales because it can work with a machine that has multiple cores, but it can also work when you have machines distributed all over the place. So it's really tuned to give parallel computing a big shot. Yeah. The library was developed by Tianxi Chen in 2014. He's from the University of Washington, and of course there's some vendors that have their own XGBoost algorithm. Yeah, I mentioned already Microsoft, they have LightGBM, and IBM of course has their own. There's probably a few more. And XGBoost is also the dominant library when it comes to competitions on Kaggle. You will go to Kaggle, you look at all the algorithms, you will see XGBoost quite often. Now, if we look at our scoring board here you have the data sets, and here you have the classifiers that we have been looking at. For gradient boosting, we will just use the same data sets and see if we see any improvement. Yeah? One thing we will take a look at before we launch ourselves into this coding session is hyperparameter tuning. Yeah? Let me point to you that during the session of support vector machines here, we did not touch IMDb and Reuters. The main reason was because the tuning of the hyperparameters, and there's quite a few in SVM, it just took forever. Yeah? So my MacBook Pro is probably not powerful enough to get all these things cleared out. Yeah? So that's why I decided not to do it. Gradient boosting has also a lot of hyperparameters. Yeah? So an easy way out would be, oh, let's not do these two, just these two. Yeah? But we're gonna give hyperparameters another shot, and we will try to do it via a different way. Okay, so hyperparameters tuning. How will we do that? Well, we will actually filter out a cross-validation set. You have your data set. We keep the bulk of the set for training, but we set some data apart for cross-validation. Cross-validation will give me the hyperparameters, and at the end we have still our testing phase. During SVMs, the parameters were tuned on the basis of grid search. And now we will see if we can have a better method that will help us find these parameters even on larger data sets, like the IMDb or the Reuters data set.